Here we go, T-minus 5 seconds. Let's listen in.
All right.
Yeah, as the crackle of the engines ripping apart the atmosphere fades out there, you can see the cloud layer that it punched through.
Yeah.
Very cool.
This was
Now, go ahead, Alex.
Go ahead. No, go ahead. Go ahead.
T plus 1 minute and 30 seconds. Real quick, I want to show something we don't often see. Look at the launch pad in the plumes on either side of the launch pad. Not going to spend a lot of time on that, but I've never noticed that before.
You can see there the chill-in of the MVAC engine from the left side.
The sort of white plume on the left-hand side of the booster there?
Yeah, they have like little tubes where they sort of like a Starship the other day.
Oh yeah, like the engine chill that we would look for before the static fire, right?
Exactly, yeah. Let's see, we're approaching now MECO. Main engine got off.
Got the curvature of the Earth in the background and the sun as well, looking back to the west. It's the view of the interstage, right?
Yep.
It is indeed. That rumble is just beginning to die out here at the Kennedy Space Center now as they're heading towards stage.
There we go, MECO. And stage separation.
Outstanding.
And now real quickly, if you blink, you miss it, the fairing is going to be separating as well.
Here we go. We got the inside of the fairing cam there.
There we go.
And fairing sep. So now you've got two cameras on the screen, y'all. Oh, look, you can see the fairing tumbling away in the right-hand side. On the right-hand side, That's the stage that's carrying the Starlinks the rest of the way into orbit. That's that Merlin vacuum engine. They switch back and forth between the two sides of the Merlin vacuum engine there. On the right-hand side, and on the left-hand side, you can see the first stage, the booster, the big main part of the rocket with the grid fins up at the top of it. It's continuing on its way down to the drone ship that's standing by out in the Atlantic Ocean to hopefully catch another successful landing.
You know, it's been a long time since the last Starlink launch, if you think about it.
How long? Months, right, Alex?
9 missions.
Yeah,
but there's been 9 launches in between. That's the longest gap they have been having with Starlink missions.
Well, you know, it was kind of. Well, you know, one of the things that's kind of interesting about that, because there was a huge, like, all of a sudden, like, everyone noticed, like, wait, customer satellites just stopped launching on everyone. And what was going on there? Well, there was an industry-wide reaction wheel problem from Honeywell that affected 90% of the satellite industry, because most satellites use their reaction wheels from Honeywell. And Honeywell was having to go back and replace and rebuild and send replacements for these reaction wheels out. So that's what caused a lot of the, nothing can launch here because the reaction wheels are bad for all the satellites. And now we're seeing that bunch up of, as they're being fixed, now it's just salvo them all off as they're actually ready to lift off.
Yeah.
What a problem to have. Like, we can't launch our satellites because the reaction wheels are bad.
I know, right?
Yeah.
It's like you have to throw out all your romaine because of salmonella or something like that, but it's reaction wheels for spacecraft.
Yeah. It really is, but like...
Oh,
We may have lost Chris there.
In fact, earlier this week, the
I think
on an Ariane 5 out of French Guiana. Actually,
yeah. Oops. We just 1 second, y'all. It's the thing where Chris, like somebody's uploading something or something like that, and we got some of his audio, but it was a little delayed. We'll give it a second. It may actually keep playing it here for a second. All right, Chris, we got you back now?
I assume.
There we go. We got you. Now, continue, Chris. Continue. Sorry.
Okay, sorry. Yeah. Everyone has to do the robot trick at one point on our streams. So, no, but the 2 Galaxy satellites that launched on the Ariane 5 rocket earlier this week actually got their reaction wheels a month ago before they launch, and reaction wheels are usually delivered a year or more before liftoff. So, yeah, I mean, the reaction wheel problem really has been an issue, and they really have just been trying to balance a lot of these launches with when will the satellites be ready to go, and really trying to lower that timeline down as much as possible.
Makes sense. Keep watching that left-hand video, y'all. The grid fins there. Every now and then you see a little blast. There was one. Those are actually the thrusters up at the top of the booster, helping give a little bit of guidance, keeping the trajectory and the attitude under control as it approaches the entry. Up here, we should get an entry burn where it lights up some of the engines down on the bottom to help it not only slow down, but what do we call it, Alex? The supersonic retro propulsion.
Yeah,
I think that's right.
Like that.
Yeah, supersonic retro propulsion.
We should be seeing that entry burn first, one engine, the center engine, and then 2 of the outer engines, E3 and E5. E1 and E5.
Gotcha.
Engine 1 and engine 5. So
you can see the grid fins turning. Oh, there you go.
There we go. 1 engine. And the other 2. All 3. Now doing that supersonic retropropulsion.
And that stage 1 telemetry as well. Look at how quickly the speed is dropping now that they've got those engines online.
And then I love the physics part of this is now it's accelerating a little bit again, and then the air grips it. And now the air is literally the only thing that's slowing it down. I love that momentary look at physics there as it's falling. Yeah.
Yep. It's getting down into the atmosphere where the air is thicker, right? You climb a mountain, you can't get enough air in your lungs because it's so thin. There's not a lot of oxygen up there or just atmospheric density for you. Same thing with the stage. I was going to explain grid fins and atmospheric density and they lost the feed. It's okay. The air gets thicker, and then the grid fins can actually start to give a little bit of aerodynamic control. Looks like they lost the feed there. That's not... it happens sometimes. It doesn't mean that there's anything wrong.
At least it's not like yesterday.
Oh, wait. You came back?
There we go.
Oh, this is my favorite shot when the drone ship just emerges.
Yep.
There we go.
Look at the effect. That. Look at the effect around the grid fin on the left. It's not a sonic boom.
Wow.
It's a vapor cone or vapor that's sort of forming around that because of the atmospheric compression that happens at these densities and speeds.
And what I love is you can see the like residuals from the engine there still streaming out the back of it, which when they do RTLS, as you can see, there's the reignition for landing. Nice.
I'm going to assume there's a drone ship somewhere under there. There it is.
With a high. There we go.
Nice.
Landed.
So that would make it now booster 1058-16 because they level up at landing. So
-16. Look at that, the sun setting in the background as the booster safely down on the drone ship out in the middle of the Atlantic Ocean. Hundreds of miles, hundreds of kilometers downrange from where they launched. They'll bring it back in. You'll see it on our fleet cam as it comes into Port Canaveral, and they'll give it a look. I was going to say, and they'll do it again, but they'll give it a look, and then they'll decide if they're going to do it again with this booster.
Yeah. And you can also see on the right-hand side of your screen there, now on the screen, there is stage 2 in its orbit. 27,000 kilometers per hour is about what we want for Starlink. So that should be, that is definitely good orbit. So just about 5 minutes now until Starlink separation.
All right, we'll have to see if SpaceX is going to let us have video of the Starlinks separating. We don't, sometimes they cut it before we see it, sometimes they show it, but we never know. It's always a It's like opening Christmas presents.
Oh, they're wrapping up coverage.
Oh, come on. It's 5 minutes.
Yeah, it's
SpaceX.
like it's in 5 minutes.
Jeez.
Keep it.
Who doesn't like to see the tumble of the Starlinks? Oh,
Fine. Fine. We'll look at the launch pad, I guess. Did we have a oh no. That was the tracking camera tracking the rocket over the horizon. It was not Chris looking for an alligator.
correct.